Assalamualaikum. So this week we are going to proceed to the next topic, topic 5, electromagnetic induction. In this video, I'm going to explain the first subtopic, which is magnetic flux. So we are going to look at two concepts here, which is the first concept is about magnetic flux, the second is magnetic flux linkage. So now let's look at the definition of magnetic flux. Magnetic flux ataupun kita gunakan simbol ni, which is we call it as phi. Okay, symbol phi is defined as the scalar product between the magnetic flux density and the vector of the surface area. Ataupun secara matematik kita boleh keluarkan di mana magnetic flux equal to the magnetic field darab dengan area cos theta, di mana angle adalah angle between magnetic field and vector A. Okay, kena take note di sini. Magnetic flux dan magnetic flux density adalah dua benda yang berbeza ya. Di mana magnetic flux density ni adalah nama lain nama lain untuk magnetic field, which we have learned this concept in the previous subtopic and in the previous chapter 4. So kamu kena tahu bezakan dua benda ni. So apa dia sebenarnya magnetic flux ni? Okay, magnetic flux ni adalah scalar quantity, which means it has no direction. So dalam perkataan yang senang, magnetic flux is basically the number of magnetic field lines that passes through a given area. Okay, berapa banyak magnetic field yang pass a particular area of a conductor or coil. Okay, itu adalah magnetic flux. Di mana the SI unit is Weber ataupun Tesla meter square. Okay, so now let's look at example. Okay, so let's consider we have a magnetic field. Okay, ni magnetic field kita going to the right. Okay, take note that magnetic field ni can go to the right, to the left, upward, downward, ataupun into the page or out of the page. Itu yang kita tahu. Lepas tu Miss letaklah satu conductor. Okay, a conductor perpendicular. So this conductor I place it perpendicular to the magnetic field. Now we can see there are a number of lines that passes through the area of the conductor. And we can find the how many magnetic field that passes through here, which we call it as a flux. Kita boleh cari apa dia flux. So based on this, the flux is equal to BA cos theta. Okay, dalam case ni BA cos theta. So macam mana kita mau tentukan theta dia? Kenapa Miss letak sini theta adalah sama dengan kosong, bukan sama dengan 90 degree? Because the angle adalah angle between area and magnetic field. So area of a plane, okay, kena take note area of a plane is always 90 degree to the plane. Ni adalah area untuk plane. So kalau kita letak plane tu macam ni kita punya plane. So ni kita punya plane, so dia punya area always 90 degree. Kita letak dia sengit macam ni, dia punya area sentiasa 90 degree. Okay, sebab area is based on the plane, not based on the magnetic field. So dalam case ni, as you can see, the magnetic field and the area, the angle between them is equal to 0. They are basically parallel to each other. So cos 0 here, cos 0 kalau kamu tekan will be equal to 1. So kita punya magnetic flux will be the maximum. Okay, so bila plane kita ni perpendicular to the magnetic field, the flux will be at the highest, at the maximum lah. Semua akan pass through the plane ataupun the area. Okay, next one, if I place the plane ataupun the conductor parallel to the field. Nah, kita letak dia macam ni. And we know that the area, again, the area of the plane always perpendicular to the plane. So from here, as you can see, the magnetic field and the area is also perpendicular. It's also 90 degree. So cos 90 kalau tekan calculator, it will be equal to 0. Maksudnya dekat sini, there is no flux passes through the plane. Okay, kamu boleh nampak lah. Tiada flux yang tiada magnetic field pun yang lalu dekat plane. So flux dia akan sama dengan kosong. Okay, next one. Okay, let's consider again the magnetic field is going to the right. Now kita ada plane ni. Okay, so plane ni Miss letak. Let me try untuk letak dia sengit macam ni. At a certain degree lah maksudnya. Okay, contohlah degree ni it's not 90. Maybe the degree is 30 degree. Okay, so macam mana kita mau kira dia punya flux? So flux will be equal to BA cos theta kan. So angle dia is not equal to 30 degree ya. In this case, the angle is not equal to 30 because the angle is between B and A. So macam mana kita mau kira tu? Okay, so we know that the area will always be 90 degree to the plane. Okay, will be always 90 degree to the plane. Dan sekarang ni yang kita mau kira adalah between the magnetic field and the area. So angle di sini lah basically yang kita mau kira kan. So angle here will be equal to 90 degree minus 30 degree, which is equal to 60 degree. Okay, so this one kamu kena ingat. The angle, kena tengok betul-betul. Angle dia adalah between the area and the magnetic field. So kalau kita letak plane to 30 degree to the magnetic field, that is not the angle. We need to tolak. Okay, tolak 90, tolak apa angle yang ada di situ. Okay, so this one kena hati-hati ya in terms of magnetic flux. Okay, next one kita tengok pula konsep magnetic flux linkage. Okay, magnetic flux linkage ni basically kita just darab dia dengan the number of the turn of the coil. Okay, basically it's a magnetic flux darab dengan number of turn. Sebab coil ni, coil ataupun conductor lah, kita ada wire kan. Okay, berapa banyak wire, berapa banyak turn yang dia ada. So kita darab lah, contohlah number of turn dia 10. So just darab sahaja. Itu beza dia. Bila ada perkataan linkage, maksudnya kita darab dengan number of turn. So unit dia masih sama. Okay, unit masih Weber ataupun Tesla meter square. Cuma darab dengan N sahaja. Okay, so let's now look at the example. Okay, example 1. Okay, example 1, a uniform magnetic field of 0.8 Tesla passes through a coil, okay, a coil of 15 turns with an area of 25 cm square at an angle of 35 degree with the coil. Okay. Now let's try to draw the situation given here. Basically macam mana kita punya lukisan di sini. So kita ada magnetic field, kita ada number of turns, kita ada area. Dan kita baca balik, angle 35 degree ni adalah between apa dengan apa. Okay, let's read again. The magnetic field, basically it is a magnetic field at angle of 35 degree with the coil. So 35 degree adalah between the coil and the magnetic field. So kalau Miss lukis, contoh ni kita punya magnetic field. And then kita letak kita punya coil. Miss letak lukis dia straight sajalah macam ni. Tidak perlu lukis exactly coil yang bulat. So this coil is 35 degree to the magnetic field. But as we know that in order to find the magnetic flux, the angle must be angle between A and B. So kita punya A always perpendicular. Kita punya A, area kita. Always perpendicular to the plane. So angle dekat sini will be 90 minus 35. Okay. So yang lain kita sudah ada value dia, just masukkan saja. Magnetic field 0.08. Area, so area here notice it is in centimeter square, so convert kepada meter square sajalah. So centimeter is exponent -2 and then dah bagi dengan kuasa 2. So it will be 25 exponent -4 meter square. And then angle 90 minus 35 will be 55. So you will get the magnetic flux is 1.15 exponent -4 Weber. Okay, next one we want to calculate magnetic flux linkage. So now just darab dengan number of turns sahaja. Okay, so magnetic flux linkage kita selalu guna N darab dengan flux, which is number of turns 15 darab dengan value yang tadi kita kira tu, which is equal to 1.75 exponent -3 Weber. Alright, next one, let's look at example 2. So example 2 here, we have a 50 turns coil with cross-sectional area 5.8 exponent -3 meter square. It's placed in a uniform magnetic field 1.5 Tesla. Okay, calculate the magnetic flux linkage in the coil when the plane of the coil makes an angle of 60 degree to the magnetic field. Again, yang 60 degree adalah plane of the coil. Okay, kalau kita lukis, ni magnetic field to the right. So dia punya plane adalah ni kita punya plane of the coil. Plane dia adalah 60 degree. Okay, so meaning that the area, okay, the angle between the area and the magnetic field is 30 degree. Okay, so in this case we want to find magnetic flux linkage. Yeah, dia minta magnetic flux linkage. So kena darab dengan number of turns. Number of turns is 50. Magnetic field 1.5. Area, okay, area is already in meter. Cos theta is not 60, sorry. Theta is 30 degree. So it will be equal to 0.38 Weber. Let me double check first. Okay, 0.38 Weber. Right, next one, example 3. Okay, this time we have a solenoid, 4 cm in diameter, 20 cm long, has 250 turns and carries current of 1.5 ampere. Now calculate the magnetic flux through the circular cross-sectional area of the solenoid. Okay, kita mau magnetic flux. Okay, now let's list down the information given. We have diameter, we have the length of the solenoid, number of turns 250 turns, current 15 ampere. Okay, ingat balik solenoid ni macam mana rupa dia. Okay, this one we learn in chapter 3. Solenoid is basically consists of conductor and wires. Okay, ni kita punya solenoid. So basically in this case ni kita punya cross sectional area and current. Okay, current will flow through the wire. So when current flow through the wire, we can find the magnetic field, right? So kalau ikutkan, magnetic field dia, okay, will be north and south. So the magnetic field will be around here. Okay, ni kita punya magnetic field. So which direction is the area? Area adalah dekat, ni kita punya cross sectional area. So this will be our area. So kalau Miss lukis, dia akan jadi macam ni. Magnetic field kita macam ni. Ini kita punya magnetic field. Now kita punya cross sectional area tu macam ni. Okay, ni dia punya plane of the conductor. Meaning that our area will be like this. So the angle between B and A is equal to 0. So kalau kita mau cari magnetic flux, will be equal to BA cos theta. Okay, but notice in this case we don't have area, we don't have magnetic field. So kita kena cari dahulu area dan magnetic field ni. So area we can find using the diameter given. And magnetic field, notice we have length, number of turns and current. We can find using a formula that we learned in the previous chapter. Di mana magnetic field untuk solenoid, nanti kamu double check formula dia adalah mu naught Ni divided by the length. Okay, ni adalah formula daripada previous chapter, chapter 4. So from here we can find that the magnetic field first. Masukkan saja value yang kita ada. Number of turns 250, current 15, length is 20 cm, so convert kepada meter, so you will get 0.0236 Tesla. Okay, and then area kita boleh cari. Okay, the area is pi d square over 4. So diameter 4 cm divided by 4, so you will get 1.257 exponent negative 3 meter square. So always leave our answer in 3 decimal places. Okay, at least ada 3 lah, so that kita punya final answer will be more accurate. Okay, now that we have the value, just masukkan saja 0.0236. Area 1.257. And then cos angle adalah kosong. So it will be equal to 2.97 exponent negative 5 Weber. Okay, so basically in this subtopic, okay, kita hanya gunakan satu formula, magnetic flux. Kalau dia minta magnetic flux linkage, kita kena darab dengan number of turns. Okay, so that's all for subtopic 5.1. 5.2 I will cover during the face-to-face class, which is next week. Thank you.